Let's talk about some joins that you won't see very often. And the reason you won't see these very often is they're just not used that often. So we're not going to spend too much time nailing down in which specific edge scenarios you may or may not use them. But just to give you an idea of what they do and what they are, it's important that we summarize the purpose and the outcome of both of these joins. So these join techniques just aren't used that often. It doesn't mean that they can't be used. And it doesn't mean you may not find the scenario in which you could use these. It is completely possible that you'll see these out in the wild. It's just not that common of a join in business cases. The first one that we're going to talk about is the cross join. Now, the cross join creates a combination of every row with every other row. So if you had 1, 2, 3, 4, and you had 1, 2, you're basically going to create a table that is going to add every row from table B with every row from table A. We call this a Cartesian product. You may have seen this from math or somewhere else, but basically it's a combination of everything with everything. And when you combine everything with everything, what you're going to see is very, very, very large data sets. So let's take a look at that. Over here, we're in Valentina Studio. And let me create a table called Cartesian A. And in that table, we're going to put just an ID column as a number. And let's create a table Cartesian B that also has that. So let's execute these two commands. And now let's comment them out. So now what we want to do is we want to insert data into these. So if we do insert into Cartesian A, and we said values 1, and let's do this a couple of times because we want a couple of values in here, 2, 3, and now let's do this for Cartesian B. And let's say 1 and 2. And let's execute these. Now, we have our data in our tables. So let's go look at it. So if we select star from Cartesian A, and we cross-join Cartesian B, what are we going to see here? Well, we're going to see the following. We're going to see 1 to 1, 1 to 2, 2 to 1, 2 to 2, 3 to 1, 3 to 2. So we're cross-joining every value from A with every value from B. And this is what we call a Cartesian product. We're creating every possible variation. And so if you have thousands and thousands and thousands of records, well, basically what you're going to see is that cross-join of all of that data with all of that other data. Not so useful in scenarios where you have massive amounts of data, but there are use cases that you could come across. So now that we know that the cross-join returns us the Cartesian product, or the combination of every row with every other row, we know the use case for it, we know what it does, and we know that it might not be as useful in most cases. The next one we're going to look at is the full outer join. Now we've looked at the left join and the right join. And what we know is that whether you do a left or a right, you're basically going to be returning the values that don't match from the right side or the left side of the join. What the full outer join does is it returns all the results from both sets, whether they match or not. So let's take a look at how that would work. Over here, we still have our Cartesian, and we can use this to do a full join. So if we did a full join, and we added an alias for B, and we did a.id equal to b.id, well, what we're going to do here is we're going to join on 1, 2, and 1 and 2. But what's going to happen? Well, we're going to return the values that don't match. In this case, we had 3. But let's look at some more elaborate cases. So let's add some more data to our table so we can see what's actually going on. So we've inserted a bunch more data into our table. And if we now go and we do our full outer join again, what are we going to get? Well, we're going to see that everything that doesn't match is also returned. So we're creating a combination where we're saying, hey, if this matches our on statement, well then return me the match, 1 and 1 and 2 and 2 match. 3 doesn't have a match in table B, 4 doesn't have a match in table B, and 5 doesn't have a match in table B. And 20 doesn't have a match in table A, and 30 doesn't have a match in table A. So we're joining, but we're saying, also return me all of the results that don't have matches, which creates more potential null values. Now, the reason this is less common is you may not find many scenarios where this data is useful to you. Most questions, a left join or a right join will answer for you. And so knowing that, we know the less common joins that you may see. And there are even more joins out there. There are some database managers that implement joins that you won't see that often. But the ones we covered here are the most common, the most used, the most seen. And with those joins, you can accomplish the most value. And with that being said, we can now jump into some amazing exercises around joins.